Good morning, students. Now, in this class, I will explain step by step in Unit 2. Topics is advanced water treatment. Regarding advanced water treatment, what is absorption and what is reverse osmosis and what is ion exchange and what is freezing and what is illustration. These processed in recent advanced process in using in advanced water treatment. Now I will explain clearly this. Guys, here the advanced water treatment, advanced here, advanced water treatment, freezing is also one of the steps. So we will explain clearly what is freezing and what is the using as a good method in advanced method. When impure water such as when impure water is frozen, I mean such as an industrial effluent, the ice crystals formed are essentially pure water. Three steps are involved in the freezing process. First, heat is removed from the water to cool it to its freezing point. Additional heat is then removed by the vaporization of a refrigerant, such as butane, in direct contact with the cooled water. This causes fine crystals of ice to freeze out of the solution. When roughly half the water is frozen to ice, the ice water slurry is transferred to another tank where the unfrozen liquid is drained off and the crystals are washed with pure water. The washed ice is transferred to another tank where it is melted to form a pure end product. So simply, just I will explain what he says in the freezing process. When impure water is frozen, when impure water is frozen, the ice crystals are formed are essentially pure water. Okay, the ice crystals are formed are essentially pure water. Here, three steps involved in the freezing process. The first step is what they will do. The first step is a heat is removed from the water to cool it to its freezing point. First, actually, that water has some heat. Immediately, we want to remove the heat. So, what we have to do first, we have to cool the water. Then only we can lose the heat from the water. So, first, what they will do, heat is removed from the water to cool it to its freezing point. Next, what they will do, additional heat is then removed by the vaporization. We have to give additional heat, that is then removed by the vaporization of a refrigerant such as butane in direct contact with the cold water. While other gases like such as a butane contacted with the cold water, when we give the supplement of the heat, that cold water also vaporization. So that is the second step. When roughly half the water is frozen to ice, The ice water slurry is transferred to another tank where the unfrozen liquid is drained off and the crystals are washed with pure water. The washed ice is transferred to another tank where it is melted to from a purer product. That is the frozen freezing. This is the one of the advanced method using in the water treatment method. Next, absorption. Absorption also is the second method nowadays using. It's a industrial wastewater treatment. Organic contaminants in wastewater which are resistant to biodegradation and are present in dissolved state are suitably removed by the process of adsorption. This is a surface phenomena. It involves collection of the contaminants on a suitable interface, which can be a liquid and a gas, a solid or another liquid. This process is used as a polishing step for improving the quality of an effluent which has already received treatment for removal of a bulk of the contaminants. Absorption occurs in the activated sludge process when the dissolved and colloidal organic matter, which acts as a substrate for micro organisms, concentrates at the biomass water interface. In the treatment of dye-bearing textile waste, powdered activated carbon is used to absorb the difficult to degrade dye molecules on the carbon along with the microorganisms. The return sludge, which contains both the carbon and the absorbed contaminants, is aerated in a separate tank. The microorganisms in the sludge consume the dye molecules, get dissolved in the process, and are returned to the aeration tank. That is the absorption. Now here, now here, filtration. Filtration is a unit operation in which a solid or a solid liquid mixture is intimately mixed with a liquid for the purpose of transforming certain components to the liquid. The example, chemical conditioning of anaerobically digested sludge. Sorry guys. I'm sorry guys. Now I will come to okay. Illustration. Uh, Illustration is a unit operation in which a solid or a solid liquid mixture is intimately mixed with a liquid for the purpose of transforming certain components to the liquid. Example, chemical conditioning of anaerobically digested sludge before mechanical dewatering can be done by washing the digested sludge with water containing low alkalinity. Such a sludge such a sludge contains a high concentration of alkalinity which consumes a lot of conditioning chemicals. Filtration transfers the alkalinity from the digested sludge to the wash water. The wash water is returned to the waste treatment plant. Filtration can be done as a single stage, multi stage, or counter current process. It is seldom used today because the finally divided solids washed out of the sludge may not be fully captured in the main wastewater treatment facility. Here, now, guys, actually, water treatment technology says here colloidal solids, colloids, turbidity, and NTU and JTU, coagulation, flocculation, and coagulating the flocculating agents, suspended solids, settling, flocculars, flotation, filtration, surface filtration, and depth filtration, slow sand filters, rapid gravity filters, and pressure filters, coliform count, disinfection, chlorination, ozonation, and UV radiation, thermal treatment, filtration, and membrane filtration. Guys, here, just a conventional water treatment plant is actually here removing colloidal and suspended solids and improving biological water quality by design, coincidental removal of other pollutants, heavy metals, colors, etc. Groundwater may need only chlorination. Groundwater may need softening, RO, defluoridation, and treatments. These are the conventional water treatment plants. Excuse me, guys. So, guys, here water, aluminum, and aluminum tank, and a lime or preparation tank. Here, a lime dosing tank are great. So, raw water and a flush mixing tank and a under slash clary flocculator, rapid gravity filter, and for backwash water, treat water reservoir or chlorinator, and chlorine storage bullet, and treated water. These are all the picture indicates conventional water treatment plant. Here, water treatment technologies is hardness total, permanent, and temporary calcium and magnesium hardness in milligram per liter as CaCO3, and water softening by lime soda process by ion exchange process and by reverse osmosis. These are all the reactions are using water treatment new technologies. Here, dissolved solids TDS at 1032, 105 degrees centigrade and 180 degrees centigrade. Ion exchange process, reverse osmosis, and vacuum evaporation, solar water stills. Here, ion exchange process. Running and exhaust of the resin and regeneration chemicals, regeneration wastewater generation, production of ion exchange resins from fouling, soft water plants, and demineralized water plants. Here, the figure indicates the first process water, brackish water to drain, and pressure sand filter from to water softener resin band from regeneration chemical wastewater to drain, and rinse water to drain, brackish water to drain, and common salt tank, and salt dose tank. So process water. These are all the. This is the one type of water treatment technologies. Here, guys, demineralized water plant. Raw water pump at ETP, raw water tank to activated carbon filter, but to raw water for brackish and brackish water. So from water for regeneration to sac resin bed. Here again, resin bed, brackish water, regeneration chemical waste, and rinse wastewater. Here, from activated carbon filter, water for regeneration, and 30% is Cl. From SCSC, resin bed, uh, degasifier, actually air from blower to degasifier. From degasifier to air and strip it, carbon dioxide and soft water for regeneration. And also soft water is just a from B to again like soft water to WB resin bed. From resin bed, backwash water, regeneration waste, and rinse waste water. From WBA rinse bed, regeneration solution and caustic solution to SBA resin bed and soft water. So SBA resin bed from backwash water, regeneration waste and rinse waste water. And here from caustic and HCl solutions, DI water and a mixed resin bed and blower, air to blower. Same result, backwash water, regeneration waste, and rinse wastewater. And from DI water to the boiler as feed water from DI water tank. This is the demineralized water plant. Here, water treatment technology says reverse osmosis. Osmosis and osmotic pressure, reverse osmosis, RO water and reject water. RO membranes and fouling and cleaning of membranes. Water free treatment and conditioning. Chlorination for taking care of iron like reduced inorganic species. Microfilters and ultrafilters may be used, may require prior dechlorination. Sodium, sodium metabisulfite for dechlorination, activated carbon absorption for dechlorination. Actually is the figure is process water chlorinating chemical to chlorination, and water for backwashing, and dechlorinating agents and the cleaning chemicals. These are all from process water chlorination, filtration, declare, and RO process and RO water. From filtration, backwash water. From RO process, wastewater from cleaning, and reject water. Water treatment technology says evaporation and condensation. Very costly and energy intensive. Energy for evaporation and for condensation. Vacuum evaporation in multiple effect evaporates, facilitates use of waste and low temperature heat, conserve energy through repeated use of latent heat. Steam economy is up to 4 is typical. Number of stages of evaporation, condensation, air finite. Boiling temperature is successive evaporators declines and difficult to operate below certain temperature. Evaporation rates decrease with decreasing boiling temperature. Here, wastewater technologies, solar water stills. Here, water treatment technologies. Already we explained absorption, granular activated carbon GAC Kalman, similar to pressure, sand filter, breakpoint, and exhausted point. Powdered activated carbon PAC is contact tank and clarifier absorption isotherms. Here, powder activated carbon tank and coagulates and percolation and clarification, sand filtration and GAC from GAC chlorine and desalination. Here, GAC as a first stage for combined filtration and absorption. Water treatment technology says absorption theories. X is weight of solute absorption and absorption milligram, and M is the weight of absorbent difference of initial and final amount of absorbate in the wastewater grams. K is the equilibrium constant. B is a constant representing monolayer coverage per unit weight of the absorbent, and C is the equilibrium concentration of adsorbate. K is free unleach capacity factor and free unleach intensity parameter. Here, membrane process. Membrane is a selective barrier permitting passing through of water and selective passing through of certain constituents of water. Particles and molecules over a wide particle size range and molecular weights range are not allowed to pass through. Mechanisms involved are a combination of sieving and diffusion mechanisms. Four common types of membranes: reverse osmosis, nanofiltration, ultrafiltration, and microfiltration, and electrodialysis. Excuse me, guys. Here, guys, this is here also the four common type membranes: reverse osmosis, nanofiltration, and ultrafiltration. Also is the very important ultrafiltration and microfiltration, electrodialysis. So here, reverse osmosis, 5 to 10 angstrom pore size of the thin skin, 0.25 micron thick over a more porous substructure limits passage of only small size molecules, size close to water molecules. Charged ions, Na plus chlorine etc., seems to be repelled by the active portion of the membrane. Pressure requirements are based on the osmotic pressure. Nanofiltration. Complementary to reverse osmosis, water softening and significant TDS removal are possible. Divalent cations and cations and anions are preferentially rejected over monovalent cations and anions. Some organics, membrane uh, greater than 100 to 500 are also rejected. Pressure requirements are based on both the osmotic pressure and the fluid mechanical frictional head loss. Operating pressure for the RO or NF is 80 to 600 PSIG. RO and NF can be applied for desalination and for the removal of hardness and are DBP precursors. Precures, precursors. Microfiltration and ultrafiltration. Microfiltration and ultrafiltration. Here, guys, ultrafiltration also one of the good treatment of wastewater, advanced wastewater treatment, ultrafiltration also, advanced wastewater treatment. But here in microfiltration and ultrafiltration, disinfection of water is possible. These rely on pure straining through porosity in the membranes. Pressure required is lower than that for RO and nanofiltration, entirely to compensate the frictional head loss. Micro and ultra filtration can be applied for conventional water treatment. Free treat water for RO and non-filtration. Removal of iron or manganese. Removal of iron and manganese after oxidation and DBP precursors. Excuse me, guys. Here removal of iron or manganese. Removal of iron and manganese after oxidation and DBP precursors. Operating pressure for the MF or UF is 5 to 60 psig. Fouling of membrane due to accumulation of solute or particulates. Buildup or formation of boundary layer cuts down the flux uh, performance of the membrane and acts as a secondary membrane, affecting the selectively of the membrane in use. Electrodialysis and ED process. The semi-permeable barrier allows passage of either positively charged ions, cations, or negatively charged ions, anions. These semi-permeable barriers are commonly known as ion exchange, ion selective, or electrodialysis membranes. Separation process, reverse osmosis, and non-filtration or ultrafiltration, microfiltration, and uh, practical filtration. Relatively size of the common materials here, micron. This is the picture. Okay, guys. Next class I will explain remaining things. Thank you.